this example, we're going to take a look at what happens when two planes intersect. So when we're in three-dimensional space and you have two distinct planes, they can be either parallel or intersect in a line. In this example, we have the situation where we have two intersecting planes, right? So here I've drawn a diagram. They're not necessarily these two planes, but you can imagine having two distinct planes, and when they intersect in a line. So I've sort of drawn that here with the green dotted line that represents where these two planes intersect. Okay, so in this problem, we're asked to, it's sort of in two parts, where we're asked to first calculate the angle between the planes and then find parametric equations for the line of intersection. So first of all, we can calculate the angle using the dot product angle formula from before. So the absolute value here just means that when we calculate the angle, it's going to be an acute angle. Because if you look at the two intersecting planes, there are actually two different angles that form. There's an acute angle and an obtuse angle. So like an acute angle and an obtuse angle. And so this calculates the acute angle between them. Okay, so first we're going to calculate the angle between them using this formula. So to calculate this, we need the normal vectors in the plane, right? So let's write them down. So n1. So the normal vector for the plane is just the coefficients of x, y, and z, right? So the coefficients here are -3 for x, 1 for y, and then 2 for z. So that's the normal vector n1. And then n2, the coefficients are -7, 11, and -1. So that's n2. So now we calculate this. So we need the dot product. So n1 dot n2 is equal to -3 times -7 plus 1 times 11 plus 2 times -1. So this is equal to 21 plus 11 is 32. 32 minus 2 is 30. And then we need their magnitudes. So the magnitude of n1 is the square root of -3 squared plus 1 squared plus 2 squared. So this is equal to 9 plus 1 is 10. 10 plus 4 is 14. So we have square root of 14. And the magnitude of n2 is the square root of -7 squared plus 11 squared plus -1 squared. So let's just calculate this. So we're squaring them, so it doesn't matter whether it's positive or negative. So 7 squared plus 11 squared plus 1 squared. 1 squared is just 1. So you got 171. So this is square root of 171. And okay, so now we can use the formula. So you have cosine theta is equal to absolute value of 30 is 30. So you get 30 over square root of 14 times the square root of 171. So theta is the cosine inverse of this thing. So let me just quickly multiply 14 times 171 for the denominator. So that's 2394. So we need, so here we're calculating in radians. So inverse cosine of 30 divided by square root of 2394. That gives me 0.9108. And converting that to degrees, you get 52.18 degrees. Okay, so that's the angle between the two planes. And so now the second part, we need to find parametric equations for their line of intersection. So for the line of intersection, I need the direction vector. So the thing about the direction vector, right? So let's try imagine drawing it in here, right? So like the direction vector could be something like this. So the direction vector is on the line, and the line is part of both planes, right? Because it's where the intersection occurs, and so because the direction vector is part of both planes, it's perpendicular to both normal vectors. So a direction vector on the intersecting line is orthogonal to both normal vectors, so n1 and n2. And so to get the direction vector, we can just do the cross product, right? Because the cross product is orthogonal to both vectors. Okay, so let's set up the calculation. So n1 cross n2, I hat, j hat, k hat. So what was n1? That's -3, 1, 2. And n2 was -7, 11, -1. So let's calculate the cross product. So for I, you have 1, 2, 11, -1, minus, and then for j, you have -3, 2, -7, -1. And then for k, you have -3, 1, -7, 11. Okay, so let's calculate this. So -1 minus 22 is -23. And then +3 minus a -14. So 3 plus 14 is 17. And then you have this minus. So -17. And then -33 minus a -7 is -26. Okay, so so this is going to be the direction vector, right? So that tells us A, B, and C. So what else do we need? We need a point on the line. Okay, so how do we find the point on the line? So the point on the line should satisfy both equations for the plane, right? So, whoops, it accidentally zoomed in. So the point x1, y1, z1 satisfies both equations. So let me write down copy down the equations again, right? So it was -3x plus y plus 2z equals 9, and negative 7x plus 11y minus z equals 30. Right, so we need to find x, y, and z coordinates that satisfy both of these equations. So what we can do is we can eliminate, say, the x variable by suppose taking x equals 0, because surely we can find a point where that satisfies the equation and the x coordinate is equal to 0. So suppose x is equal to 0. So you got two equations, so y plus 2z equals 9, and 11y minus z is equal to 30. So we just need to solve these equations, and we can do it by, say, elimination. So say y plus 2, so keeping the first equation the same, multiplying the second one by 2, so you get 22y minus 2z is equal to 60. And then now we can add the equations to eliminate the z variable, as you get 23y is equal to 69. So dividing by 23, you get y is equal to 3. So x equals 0, y equals 3, and now we can calculate z, say plugging it into here. Right, so 3 plus 2z equals 9. So 2z is equal to 6, meaning z is also equal to 3. Okay, so we can take 0, 3, 3, and you can quickly check that this satisfies both equations, right? So when x is 0, this is 3 and 3, so 3 plus 6 is equal to 9. And then here you have 33 minus 3 is equal to 30. So these coordinates check out. And so now we can write down the equation, right? So this is my x1, this is my y1, and this is my z1. So the equation of the intersecting line is going to be, so the parametric equations again is x equals x1 plus at, y equals y1 plus bt, and z equals z1 plus ct. So x1, y1, z1 is 0, 3, 3, and what was a, b, and c? That's what we calculated previously. So it's negative 23, negative 17, negative 26. So minus 23 t, and then this is minus 17 t, and then the last one is minus 26 t. Okay, so this is my set of parametric equations.